So this first one here, now, this is very important. The first thing that students will have misconception is this. They straight away say x bar is normally distributed with mu over sigma square over n. This is wrong. Okay? Cannot write like that. This is wrong. Why this is wrong? Because this is not normal. Cannot assume it's normal. Your sample will only be normal if your population is normal. But if it's not, sampling is very, very strict. So this could be discrete random variable. It could be binomial distribution. X1 could be binomially distributed. It could be Poisson distribution. It could be any kind of other distribution, Pareto distribution or whatnot. Okay, as long as they never say it's normal, you cannot write this down. This one cannot appear on your worksheet. Cannot. Cardinal sin. Okay, so what you can only write is this one here for sure. Okay, so this one just now we did already lah. So the population mean. So the random sample of n taken from the population mean mu and this one. If x bar is a sample mean, show that E x bar. So it's okay lah. So x bar, if it's a sample mean, this case here will just be x1 plus x2 plus x3 all the way to xn. This divided by n. So what you need to do is just like what we did just now, 1 over n, x1 plus 1 over n, x2, 1 over n, xn. Then you just expectation of Ex bar is actually exactly the same. Guys. Nothing interesting there. So this will be just expectation. So it's 1 over n ex. It's n. Because we have n times of it, so this will be ex. Okay, and then this will just be ex is mu lah. Okay, because we have n times on it. You have n times of this lah, this rubbish here. So you can only write. You can't write this. You can only write this one out. So then the variance, same thing, var bar x. Square the constant in front. And the last one. Okay. So this case here will give you n times 1 over n square variance x, and this will just be 1 over n variance x. This will just be variance x will just be sigma square. Okay, good job. Check, man.